The next question in this exercise, question 13.3.5. The following table gives you the distribution of the lifetime of 400 neon lamps. Find the median lifetime of a lamp. We know that median is that value which represents the midpoint of the observations. So if you arrange the data set in either ascending or descending order, it's the exact middle value. Let's see the table. We have been given 400 different lamps, and each lamp has a lifespan. So that would be counted in hours. So there are 14 lamps. They last between 1500 to 2000 hours. 56 lamps between 2000 and 2500 hours, and so on. Altogether, there are 400 lamps. When you are finding out the median, it's very important to find the middle value. So for that, we are going to create something called cumulative frequency. We are going to make another column which stands for CF, cumulative frequency, and we are going to create numbers by addition. So the first number is as it is, whatever is the frequency, we simply have to copy for the first record. Then the second one will be added 56 to it. So 14 plus 56 will be 70. Remember, it's cumulative. That means the numbers are going to be accumulated. So there are, what is the meaning of this 70? There are 70 lamps which last less than 2500 hours. So if you extend that logic, 70 plus 60 will be 130. 130 plus 86, that will be 216, plus 74 will be 290, plus 62 will be 352, plus 48 will be 400. Now, if you are accurate, this last number in the cumulative frequency table should exactly match with the total number of observation. If it is not matching, that means you have made somewhere mistake. Go back and check your calculations. Now, since the total number of lamps is equal to 400, if you arrange them in ascending or descending order of their lifespan, we are particularly interested in the middle value, which is the 200th bulb. Whatever is the lifespan of the 200th of the bulb, if everything is arranged in ascending or descending order, that would be your final answer. So first of all, we have to find out where exactly is this 200th bulb is hiding. So number of observations is 400. We always divide by 2 because we want to find out the middle of that observation. So 200th bulb will be somewhere here because according to our cumulative frequency, 216 bulbs have lifespan less than 3500 hours. So our 200th bulb will be somewhere between 130 and 216. So that would be in this particular class interval. So now we can write it down. Median is in this interval. Now there is a formula for the median. We don't know exactly. We know only the thing that this is in this class interval. Whether it is 3000, whether it is 3500, whether it is in between, that we do not know. The precise value of the median will be calculated using this particular formula. This involves, let us see the meaning of each individual term. L stands for the lower of the class interval. So since this class interval has the lowest value of 3000, so that would be your L value. N by 2 we have just calculated as 200. Cumulative frequency of the previous class. Now, our median is in this interval, so the cumulative frequency of the previous class will be 130. Frequency of the same class, so that would be 86. And finally, the class interval, which is every class interval is 500. So the difference between 3000 and 3500, and for that purpose, you can take the difference of any class interval, it doesn't matter. It's going to be uniform anyway. So that H is the interval, that is the width, which is 500. Now it's a matter of substitution. Let's substitute these values. 200 minus 130 will come out to be 70. We can further simplify that. 35 divided by 43. 35 you can multiply with 500 and manually divide by 43. I know it will be a little bit time consuming, but your final answer is going to be 3406.98 hours.